Hi, welcome to the Shuttle Mathematical Statistics lecture series. And today's the problem we're going to solve is another maximum likelihood estimator problem. See here. So let's take a look. See here. So we said consider a sequence of a i.i.d. random variable from a normal distribution with the mean is equal to the mu, and the variance is sigma square. And also we define M2 prime as the second moment here is the summation I from 1 to n xi to the square over m. So the first, let's assume since the normal distribution have two parameters, right, mu and sigma square. So in this video, we're going to talk about how about if sigma square equal to mu. Then I want to find the maximum likelihood of the mu, and we can say that we can show the MLE, the mu hat, is a functions of the second moments here. All right, so okay, let's go ahead, go to the whiteboard, and let's take a look at how do we solve this problem here. Okay, so here is a whiteboard here. All right, so let's go ahead and do it. So before we do the MLEs here, so let's try to write down my functions, right? So f of x. So if it's a normal distribution, I know the PDF is the square root of the 2 pi sigma, and then this is e the minus 1/2, and this is x minus mu to the sigma squares here. Okay, so now let's take a look. First things, like when we find the likelihood functions, we always find the MLE, we always need to find the likelihood functions, right? So we said LXYN, so that means your times here, so it will be, so this will be the square root of the 2 pi, you times n's, right? Then you will have the sigma in here. So for this situation, we assume the sigma square equal to mu. So the sigmas here will just be the square root of the mu and times n here. Okay, and then this will be e to the negative 1/2. Now here's the sigma square on the bottom. So sigma square is equal to mu, so this is mu. And then the top will be x1 minus mu square times x2 minus mu square. So the top will be xi minus mu square, right? So I from I to n. So this is my likelihood function. So like we did before, let's take the log of this likelihood functions. And in here, we mean the natural logs here. And so then this one's here by using the log properties here. So I will have negative n over 2. Then this will be the log and 2 pi's, right? Okay. Then minus n over 2. Then this is a log u. And then you take log and e cancel. So this will be 1/2. And this is the mu, and this is the summation x1 to n, xi minus mu, the square. And just like we did before, when you try to find MLE, I'm taking the first derivatives, right? So it's a log function with a likelihood, and I'm taking the derivative respect to the mu's here. All right, so here, the first term, this is a constant, so we cancel. So the next one is n over 2. Then the log mu is just equal to the 1 over mu here, all right? So then the next one's here, so this will be minus 1/2. Okay, so here we need to be a little bit careful because the mu is on the bottom, mu also is on the top, right? So this is really tests you to see how good you remember your calculus rule. So now I use the portion rules, right? So I square the bottom, so it's mu to the square. Then I take the derivative of the top and hold the bottom. So the derivative of the top here, this one will be 2. So I hold the bottom as mu times 2. and then the times xi minus mu, and I from 1 to n, and then the chain rules here, right? So don't forget the chain rule, so you have a negative signs here. Okay, and then minus, you hold the top, right? So the top will be summation I from 1 to n, xi minus mu to the square, the whole thing times the derivative of the bottom, so it's 1. Okay, okay, so now in here, we just need to be very careful and do a lot of algebras here. So you can factor the negative 1/2 out. Yeah. Okay, so for the negative 1/2 out, so the first ones here is will be n and the mu, right? N over mu. Then plus, okay, so here this is a big equation, right? So this is mu to the square. So this is 2 mu's here. Okay, so now I like to take this one out so be able to see better. So this one will really be what? Will be the summation xi minus n times mu, right? Okay, so this one then I need to times the negative 2u to the front. So the first terms will be negative 2 mu, then summation xi, okay? Then plus, this is minus is plus, right? So plus 2n mu squared. Okay, now these terms here, I also like to separate it out so we will have a better clear view. So this will be I from 1 to n. Then this will be xi squared minus 2xi times mu plus mu squared. So this term will be summation I from 1 to n, the xi squared minus the mu. All right, so it's a minus, you can factor the 2 mu and the summation xi, and then the last term, you're going to have n terms, right? So it's n to the mu squared. Okay, now in here, remember here, don't forget, here we got a negative in front of it, right? So need to be very careful. So it's a minus summation xi squared I from 1 to n, okay? Then minus becomes a positive, it's a 2 mu summation xi I from 1 to n. Negative or positive is negative, right? So this will be the negative n mu square. All right, so we get this big things. Okay, now let's take a look here. So the n mu, so 2 mu, so this one and this one will cancel, right? And this is a positive 2n mu, this is negative n mu, so I have 1 n mu left. Okay, so now let's see here. So this is negative 1/2 n over mu still here. And then here I have here, this is a mu square. And I have 1 the n mu square. And what I have here, I have 1 the n mu square. Now I have this minus summation xi square. Okay, now let me combine these two terms. Find the common denominator is mu square. So here's n mu, right? So this term will be n mu square plus n mu, right? So this n mu is from combining these terms, right? Because a common denominator, and then minus the summation xi square. So this is a derivative. So we said that MLE is to set the top equal to 0, right? So let's find a solution for mu. So I have mu square plus n mu minus summation xi square, and I will set it equal to 0. and try to solve for mu. So in here, now I'm using the quadratic function. Okay, so for the quadratic function, so the mu, I know the mu, the one of the quadratic function mu hat will be 2a, so it's 2n, correct? Then minus b, so b here, so let's put notations here. So this will be my a, and this will be my b, and this whole thing is my c, right? So I use the quadratic formula. So it's 2n negative b, so it's negative n, and plus, then b squared, so it's n squared, minus 4ac, so it's a plus, right? 4n, and the summation xi squared. Okay, so people might ask me, say, why the quadratic function? So typical we put a plus minus here, right? Why you only put a plus? The reason why I only put the plus is these reasons here. Okay, so take a look here. Because the whatever I have inside, the inside the square roots here. Okay, so this is the n squared plus something positive. So this whole square roots here, this whole square roots is going to be greater than square roots of the n squared or greater than n. So that's why if you put a negative sign here, if you put a negative sign here, plus minus, then the whole things will be negative. But then in here, we assume the sigma square equal to mu square. So I cannot have negative. So that's why in here, this is plus. All right, so that's the plus here. Okay, so we're almost there. So now I can, okay, so here, this is 2n. So this is negative n plus, and now I have take the n square out, factor the n square out, this is 1 plus. I take the n, here is only have n, so what I need to do is here, I need to 4n, then summation xi square. That's right. Okay, so the reason why I want to take this one out, so I can, this is 2n, this is negative n, I can take this n outside the square roots, then this is 1 plus 4. Okay, so take a look at summation xi square over n, right? Summation of xi square over n, this is what we defined to be the m2, the second moment, right? So we define the m2 is equal to the summation xi square over n's here. So we know this terms here is the second moment. So that's why we say this is m2 primes here. So now the last step, because this is n, you can cancel that out. So it will just be the 2 negative 1 plus, this is 1 plus 4 and 2 prime. Okay, so that is the MLE. So this is the MLE. So this is the MLE for the what? For the mu's, right? Okay, so if we assume the sigma square equal to mu, so okay, that's it. And our next video is we're going to find the MLE for mu. Instead of the sigma square equal to mu, we will assume mu equal to the standard deviation. Then let's see what is MLE for mu here. I'd be interested here. All right, that's it. Okay, nice talk to you, and looking forward to work with you for our next problems here. Okay, bye-bye.